All right, guys, let's go ahead and talk about naming ionic compounds. When you name ionic compounds, just like when you write formulas, you've got to make sure that you name the cation first and the anion second. It's going to be in the same order as the formulas are. And a way to remember that is your periodic table. If you'll just remember, metals are on the left, nonmetals are on the right of the periodic table, and they go in that order when we write formulas or when we name. Now, go ahead and get your naming compounds worksheet out that I gave you, and you can follow along with it as I go through the video because I actually use that worksheet for the video. I talk on the video about ionic naming and covalent naming, but go ahead and watch all of it because we will be talking about covalent naming in the future. So make sure that you watch all of that, and we'll work on naming ionic compounds once you come back to class. And I'm using a worksheet that you have, and so you can get it out if you'd like to follow along with me, or if you'd like to watch the video and then look at it later. Whichever one you would like to do is fine with me. Now this is a worksheet from Stephen Murray, and he's a science teacher that releases some of his worksheets to be used in the classroom. And I believe he teaches us in a really neat way. So let's look at how to name compounds. We've already talked about ionic, covalent, and polyatomic compounds. So we know how to tell the difference between those. Now we need to learn how to name them. So the first question you ask yourself is up here at the top. And it tells you to ask, what's it made of? So this is your first step. So number one is ask yourself, what's it made of? And so then you determine, is it a metal and a nonmetal? Are they two nonmetals? Or is it three or more elements? And those three things will tell you then which type of compound it is. If it's a metal and a nonmetal, let's move this direction and follow the arrows. If it's a metal and nonmetal, we know we have an ionic compound. When we have ionic compounds, what you do to name it is you always have two elements. And so the first element is always the metal. The second element is always the nonmetal. So if we have, let's see, NaCl, the first, which is the metal, stays just like it is on the periodic table. The metal never changes. You always label it like its name is on the periodic table. So we say sodium. However, for the nonmetal, we always change the ending to IDE. And chlorine is our nonmetal. So we just take chlorine and we change the ending to IDE. So for this, we would name sodium chloride. Now let's move on down to the example that he has for us. LiS. I'm going to underline the metal. So lithium is our metal, so it's going to stay the same as you can see down here, lithium. It stays the same just like it is on the periodic table, but the nonmetal, which is what I will circle, the nonmetal is, we change the ending to IDE, so we say lithium sulfide. So this shows us that we just, for ionic compounds, that you keep the metal the same name it is on the periodic table. The nonmetal, we just change the ending. Now let's go back up to our first step where we ask, what's it made of? If it's made of two nonmetals, we know we have a covalent compound. And you name covalent compounds exactly like you do ionic. The only difference is you use Greek prefixes. Okay? So, but you name the rest of it the exact same. So the first element that you have in the compound, the covalent compound, you keep its name that it has on the periodic table. The second name, you change the ending to IDE, but you add prefixes. So let's look at an example. If we have, let's say CO2, because this shows you there is one rule that you have to remember with covalent. You never use the prefix mono for the first name. And in just a second, you'll see the list of prefixes. And if you have your worksheet, you can actually already see them. But mono is for 1, di is for 2, tri is for 3, tetra for 4, and so forth, penta for 5, and so forth. So we're going to use those prefixes to name the covalent compounds. Now, normally you would think you would put monocarbon, but we never use mono in front of the first element. We only start using mono with the second element. So we would name this one carbon, just like it is on the periodic table. Di for the 2 right here, because it tells us how many atoms. Oxide. So if this was an ionic compound, we would just call it carbon oxide. But it's not, it's covalent, so we have to make sure we add those prefixes, carbon dioxide. Now let's go down and look at their example. The first nonmetal, as you can see, is nitrogen. So it stays the same, just like it is on the periodic table, except since it's covalent, we have to tell how many atoms are in it. So we say dinitrogen because there are 2 nitrogen. Now, oxygen, which is the second nonmetal, as you can see, is named oxide, and there are 4 oxygens, so we say tetroxide. So this name is dinitrogen tetroxide. So you name ionic covalent the exact same way, except with covalent you use prefixes. Now, let's go over here up to our first question, what's it made of? And if it's made of 3 or more elements, we have a polyatomic compound. And with this one, you use no prefixes again. Covalent are the only ones you use prefixes, all right? So if the polyatomic ion is the cation, if your polyatomic ion is the metal, then you're going to end the second name with IDE. Now, there is only one polyatomic ion on your chart that is a positive ion, and that's ammonium. So if you use ammonium with anything, like ammonium and oxygen, it's going to be ammonium oxide. If you put ammonium with chlorine, it's ammonium chloride. So you will change that ending to IDE. All of the other polyatomic ions we're going to be working with are going to be the anions. And so you don't change that name. You always use the name that's on the chart. So, for instance, if we have, let's see, let me think of one. If we have, we did this in one of our other videos, LiCN, okay? We keep the metal the same as always, just like it is on the periodic table, so we're going to say lithium. And since this is our polyatomic ion, you put the name that's on the chart. And so we just say cyanide. Okay? Let's look at their example down here to give us a second example. Down here they have NaNO3. And that's 3 different elements because there are 3 capital letters. That means we've got a polyatomic ion. Now, sodium, Na, is sodium on the periodic table, so it's going to stay that way. And on your chart, you will see that NO3 is nitrate. So we have sodium nitrate. Again, whenever you use a polyatomic ion, you're always going to use the name that's found on the chart. Okay, I've moved down on our worksheet, so now you can see the Greek prefixes. And so those are what you use in front of the names of elements for covalent compounds. It also gives you some hints on how to remember them. You will have to memorize those Greek prefixes for the test. Then you have a polyatomic ion chart to the right, and those are just some common polyatomic ions that you've seen before. Now, one thing is you will not have to memorize those. I will give you a chart of those for the test, so don't feel like you have to memorize those. Now, there's one last thing we need to talk about naming, and that's transition metals. Remember that transition metals, they're still going to form ionic bonds because they're metals with nonmetals. However, they change charges. In our group 1 and group 2, they always have a 1+ charge or 2+ charge. But in groups 3 through 12, they change charges, so they're not always the same. So there's a couple of different things that we have to do with them. So look down here for your transition metal box. See, iron can have a 2+ charge or a 3+ charge, and the way we designate that is the 2 and 3 in Roman numerals in parentheses. So if you see that, you know it's iron 2. Now, when you're naming transition metals, you have to specify which one you're naming. Now, let's look at the example that they have. They have iron oxide, and so let's see, FeO. Let's do the second one they have listed. What you do to figure out which transition metal you have, you do reverse crisscross. Remember, these numbers came from the original charges. So it means that this 2 actually goes back up with oxygen to give oxygen a 2+ charge. A 2- charge. Oh, I apologize. So we'll write 2-. And then this 3 came from iron, and since iron is a metal, it's going to have a positive charge. So iron, it tells us there that iron had a 3+ charge. So to name this, and this is written on your worksheet, But to name this, you have to say iron and then designate that it was the one with the 3 charge. All right? And then you can say oxide like you would normally do. So whenever you have an ionic bond, look to see if the metal is a transition metal. If it is, you need to do the reverse crisscross to determine what its original charge was and add that charge into the name with a Roman numeral. All right, I would like you to do a summary now. So to summarize today, I would like you to write the 3 most important things that you learned from this video that would summarize the video for someone else. So write down the 3 most important things you learned, and we'll practice this in class.